Okay, hello. All right, cool. And I've got two friends here to come and watch the lesson. I'm very excited. Right, where are we? We are going to still solve a system of linear equation. Also three variables. And we're going to learn about a different way of doing it, which I think is easier. Okay? But it starts the same. So maybe you guys can help me. Okay, so we've got three variables. Okay? What we learned last time, that we need to find some kind of, turn it into a matrix equation. Okay? So we're going to have the coefficient, or the matrix of coefficient, okay? Which in this case is 1, 2, minus 3, 2, minus 1, minus 1, 3, 2, and 1, okay? And if we take that, that's just the coefficients. And if we multiply by a column matrix, which is the variables, x, y, z, that's going to be equal to the column of the solution, 3, 11, minus 5. Okay? And this is in the way of, we're writing this as in matrix, it's a matrix equation. Okay? We can write it sometime in the literature, it would look like this, ax equal b. Okay? That is this matrix of the coefficient. This x, it's a little bit confusing. I don't use this form too much because this is not just one variable. This is x, y, z. So I don't want to confuse you too much. Maybe let's do it the way I've done it last time. So it's like this fat matrix, x, y, z. And here we're going to, I don't know how I called it before, a, b, c or something. It's basically these are numbers, these are numbers. And then do you remember how does that help us? What do we do then? Okay. So we want to get rid of that a.
Oh, we find the inverse.
Inverse. So we multiply both sides of the equation by a minus 1. So we're going to write a minus 1 times a.
You're going to get the identity.
That's it. Okay.
So it's basically just 1,000.
Yeah. Equal, but I need to multiply, the price I have to pay, I have to multiply this a, b, c, these numbers by a minus 1. And then really this is the identity matrix. So I can basically erase it. And then I find x, y, and z. Now, this is a good method to do if you've got a calculator that you can calculate the inverse matrix. Because remember, we had a couple of lessons on how to calculate, and that's the process in itself. Okay, so if you've got a calculator, okay, and you know how to listen to Indian accent, and you can understand that video that I gave you, then that's no problem. That will be the way to do it. But let's say you don't have a calculator. Alright? It's just because that explanation video was in some Indian guy. Yes. Okay, so yeah, there was a question here. Can you use the calculator? And yes, absolutely. If the calculator helps you, definitely use the calculator. Find the inverse and find the solution. But let's say for some reason you're not allowed, they tell you not to use the calculator, then what do? What we do is we augment this matrix. We get rid of, okay, what I'm going to do, I'm going to show you what you do it, and that's going to annoy Arne a bit, but I'm going to show you what to do first, and then when we know what we're doing, then we're going to try and figure out why it works. Okay? It's a little game. Sometimes we have to explain first and then show, and sometimes it's the other way. So we're going to take this matrix of the coefficient, we're going to get rid of this variables, and we're going to augment this matrix like we did it for the finding the determinant. What are we going to add to it? Well, we're going to add exactly that column of the answers. Okay? So now I have like a, what do you call it, a 3 by 4 matrix, which is combined of the coefficient and that solution. And what I want to turn that into, okay, I'm just going to pause, I'm going to write it down here so I can use more space on the board. Okay, so what I want to turn that into is, it's called, we're going to use row reduction, which I'll remind you what it is, we've learned that, to turn into what we call it reduced echelon form. Let me just write it down, so it's not crucial that you know that. Reduce echelon form. Reduce row echelon. I don't know. Okay? Reduce row echelon. And if you want another bombastic name, this whole system is called Gauss-Jordan elimination. Gauss is a name that you come across a lot in the university. What do you want to turn it eventually? I'll write it down here. You want to turn it into these entries. These 3 entries must be 0. So here you have a number, I don't know what, we'll call it A, B, C, D, E, F. This is G, H, K, or whatever, A, B, C, D, E, F, G, H, I. Okay? You want it to turn into this. In other words, you want 0 entries. Why? Well, I'll show you why. And, okay, so what is row? And we do that all by row operation. So what is row operation? Row operation, you can add rows together, you can subtract rows, and you can multiply them by a number. So we'll leave that. That is fine. The first row, it's just as it is, it's fine. Okay, I'm going to start here. Can I stand here? I'll stand up. All right, 1, 2, minus 3, 3. Now, I want to get rid of that 2. I want it to be 0. Reduced echelon, by the way. It looks like a step. You want it to have a step. Okay? So I want to get rid of that 2. How can I get rid of that 2? Using the first row. You normally will use the first row. I can multiply that row by 2 and minus them together, right? So I'll write down, maybe we'll call this R1, row 1, row 2, row 3. Row 1 is going to be left as it is. Row 2 will do 2 times row 1 minus row 2. Can you see what I'm doing here? 2 times that minus that, because then that will be 2 minus 2 will be 0, which is all I wanted for now. 2 times 2, please check me guys, you know me. So 2 times 2 is 4, minus 1 is 5. Minus 6, minus 1 is minus 5 if I'm not mistaken.
Is it?
Okay?
Yeah.
So?
Am I? Yeah.
Then you say minus 2.
So which one? This one?
The third row.
Third row. So minus 6.
Oh, sorry.
Yeah. Minus 1. Yeah, minus 5. 6 minus 11 minus 5. Is that right? Okay. Now, alright, now we want to get rid of the 3. So we will do it in 2 steps. So first of all, we'll use, I would use the first row, it will be easier to get rid of that, yeah? So we're going to do it, do you want to have a go? How can we write it?
Well, 3 times R1
minus R3, right? So 3 times R1, so 3 minus 3, great. So it's going to be 0. 6 minus 2 is 4. Minus 9 minus 1 minus 10. And then 9 minus 5, 14. Let's just pause here and just make sure I didn't do any blunders. Alright, so we're moving on. The first row, I'm going to leave it the same. 1, 2, minus 3, and 3. Second row, if you don't mind, I can leave it like that. Because, you know, I've got already a 0 where I want 0. I've got numbers here, that's fine. But what do you feel like? What should we do here?
You could take out a 5.
Divide by 5. Okay? So if I can, like, by multiplying by a fifth, right? I can multiply a row by a number. So if I multiply the first row, I'm going to write it down. Let's do it in blue. So let's just take R2 and divide it by 5. It's just going to make it much simpler. I don't have to do it, but it will be silly not to do it. Minus 1. Okay? And then, Olivia already said, to get rid of that 4, what I can do is multiply. So I can do 2R1 minus the new R3. Yeah? So it will be 2 times 2, 4. 4 minus 4 is 0. No. That's not going to be good. I can't use row 1 now. Why can't I use row 1? What will happen if I do that? Yes, I will get rid of that.
Get a 1.
Then I'll get a 1, or it will be actually 2. Right? Because I multiply 2 times R1, it will be 2 minus 0. Then I'm stuck with the 2 here. So once I've got him, he's got the number of zeros, then I can't use R1. I've got to use this one.
Okay.
Now, again, I don't really want to use this one, but I could use this one. Yeah, because now it's 1. You know, a 5 and a 4 is a bit difficult to kind of sort out. But let's use this new row 2. So how should I do it? How many? 4. So yeah, 4 row 2 minus row 3. And I'm kind of being a little bit dishonest because it's this row 2, not this row 2. You know what I mean, okay? So now it's going to be, that's still 0, and I can use that because I've got 0, so 0 minus 0 is 0. 4 times row 2 is 4, 4 minus 4 is 0, and then minus 4 minus 10 is a 6, is that right? Yeah, we'll check in a minute, hopefully I got it right, and then minus 4 minus 14, I think I've got minus 18. Let's just pause.
Minus. Oh, it's negative.
That's positive. So minus, yeah. Okay. I'll just pause just to make sure. I think we got it right. So look, at this point, I'm in what you call reduced row echelon. Reduced row echelon is that I've got those zeros are 0 and the rest are numbers. I could already show you how you get the solution now, but again, it feels like I want to do one more thing. Okay. What would I do with the third row?
Take out 6.
Divide by 6. So let's do one last time. You don't have to do it. You'll see in a second what happens if we don't do it. It's still going to work, but eventually we will have to do it in this way or another. So now I have 0, 1, minus 1, minus 1, 0, 0, 1, and minus 3. I just divided the last row by 6. Okay? Now, what does this thing say? We've got some augmented matrix, but remember we started with the system of linear equation. So we can rewrite this thing. Okay? This is the matrix of the coefficient. This is the column of the variable. And this is the new column of the solution. Okay? So what does this thing say? This says that 1x, I don't need to write 1x, right? It's x. Well, actually, no. I don't want, wow, shall I do that? Yeah, I can do it. Okay? But normally you're not going to have to do it. Normally you'll get your solution straight away. But this is the first time. So we're going to write this again. This is the matrix of the coefficient. So we're going to be x plus 2y minus 3z equal 3. What does it say here? There's no x's.
Okay.
You see what I'm doing?
When you get the z.
Y minus z equal minus 1. And the last one said z equal minus 3. I'll write it here. Z equal minus 3. You can see it. And you can see I deliberately wrote them down in like a staggered row echelon because this is what we're doing. Right? And I didn't prove to you why we can't do it. I won't prove it to you, but I will try and convince you after. Okay? And yeah, that's it. Now that we can solve. Okay, I'm going to get rid of that because I don't need that. So the first part, what solution we already have? We have z equal minus 3. And then we can just put that in here, right? So we can write, well, if that's the case, we'll add those two. Y plus 3 equal minus 1, right? Just plugging in z equal minus 3. And that means that y equal minus 4. Let's circle that one. Okay? And then, once I've got those two, I can plug them in all in the last equation. So x plus 2 times minus 4, okay, minus 3 times minus 3 equal 3. And you can find x, right? X minus 8 plus 9. So it's plus 1 equal 3. X equal minus 2. Hopefully didn't make any mistakes here. No, they got x equal 2. Ah, no, it is x equal 2. Okay, minus 1. So we've got 2. They got, where's the answer? 2, z equal minus 3, and y equal minus 4. Perfect. Okay, I'll just pause here. See where we're going from here. Okay, so here, there's two more things I want to talk about. We finished. We found the solution, the x, y, and z. And let me say it was a unique solution. Let me just put in that word there, because that's our next lesson. Unique solution means x had one value, y had one value, and z had one value. Next lesson, we're going to see where they can have more than one value. But now I want to do the first thing is, I told you that we need to get to reduce row echelon. Where I told you, okay, these must be 0, and these can be any numbers. Now I eventually, just because I couldn't help myself, I just turned them all to 1. If they're all 1, then it makes our life easier. Why does it make our life easier? Because now, let's write it again. Okay? I wrote down the whole system again, but actually I don't have to write. I can just imagine it. I can see, look, what this thing is. This tells you the coefficient of which variable? Z. So already that equation tells you Z equal minus 3. Yeah, so I showed you once how to write the whole thing, but from now you can say, okay, that just basically tells you the Z is 3. This one, what does this then tell you? Okay, remember this is like your X, this is your Y, and this is your Z. So this row tells you that Y minus Z equal minus 1. Okay? Can you see it? I'm trying to teach you how to read these equations. This one will tell you that X plus 2Y minus 3Z equal 3. So as I told you, we just basically got our first row to just have the Z. That's the whole idea. But let's say now we left it there. Okay?
Yeah.
So, okay, let's try and write down what does this thing tell us. That's going to tell us the same thing. We didn't change anything. X plus 2Y. Well, I'm not going to write it. Okay? It's the same. Those two are the same. What would this row tell us?
6Z equals minus 18.
Okay, which is obviously the same as that. 6y, z minus 18. So you can leave it there. If you want, you can even leave it as 5 and minus 5. Then it's just going to tell us 5y minus 5. So you don't have to go to 1 like that. It's only if you want to. Okay? I can tell you even more. If you're really OCD, I stop here, and I'll be honest with you, I often won't divide. Like if let's say this was 2. Let's say for the sake of it, let's say this was 2. I would personally leave it like that. Because I divide by 2, then I have 5 of it. I'll just leave it like that. You know what I mean? Okay? So you don't have to. Just because it was 5 and minus 5, everything was so easy to divide by 5. The same thing. So easy to divide by 6. I did it. But normally I would just leave it in numbers. But the really OCD people won't even stop here. What they will carry on, I won't write it now. And I'm not going to do it. It's just too much work. But they're going to carry on doing raw operation, try and get rid of more numbers. Which numbers we would like to get rid of, do you reckon? Yes.
You want to get just an X and Y and a Z.
Exactly. We want to eventually have X equals something, Y equals something, Z equals something. So which numbers do I want to keep? Let's put it this way. They're diagonal. So what I want eventually is to have 1, 1, 1, 0, 0, 0, 0, 0. It's what we call the identity matrix. Okay? And here we're going to have a bunch of numbers. I don't know. Well, we can figure out what number it is going to be now. No, because I erased the solutions.
That's the same as the other.
Yes, yeah, we turned that into identity, and then, but then what we augmented was the whole matrix.
Yeah.
Here we just have that. Now, you guys can tell me, I erased the solution, unfortunately. But if we carry doing raw operation, what would be these numbers?
The answers.
The answers. So just tell me what the answer is. Z was equal minus 3. Y was minus 4, I think. Y was minus 4, and X 2. You understand what I'm saying? So I'm not expecting you to do it, but some people might carry on doing it. And then there's nothing you need to do. This tells you Z equal minus 3, Y equal minus 4. But obviously you have to do a lot of things. Because now, to get rid of that 2, what do I want to get rid of that minus 1? Okay, you know what? That's easy actually. Stand here. To get rid of that minus 1, so this row will be 0, 1, 0. I'm just going to add these two together, right? So it can be done. Some people like that. Okay? Again, I'll pause and then we'll try and explain like why does it work? Okay, so now why does this system work? Why does this method work? And why actually it's called Gauss-Jordan elimination? Okay? Never mind these names, Gauss and Jordan, but why is it called elimination?
Because you're getting rid of
We're eliminating variables. Should stand here. Let's just do, what did we do in the first thing? So we left the first row, and then what we did, we got rid of that 2, remember? By adding 2R1 minus R2. Then it turns to 0. Okay? Now, we eliminated the certain variable. Which variable?
The
X.
The X.
Yeah.
Now, forget about matrices and all that time. Let's just look at these two equations. I'm not going to look at that one yet. I mean, it's difficult, you know, but you know elimination. We're just getting rid of variables. So if I call this equation 1 and this equation 2 and this is equation 3, I want to get rid of the x. How do I do it? Well, I'll take, how did I do it? Using these two equations. How do I get rid of the x?
Just 2 times 1.
2 times equation 1 minus equation 2. You see what I'm saying here? So that's going to be, well, 2x minus 2x will be 0. So it will be 4x minus 5, minus 4y minus 1 is 5y. Okay, I'm going to just write it bracket. Right, 4y minus was 5y. No, that's 2. Minus 6 plus 1, so it's minus 5z, equal 6 minus 11 minus 5. Does that look familiar? It looks very familiar. Can you see that? This row is exactly that, just without the variable. So what we're doing is elimination that you learn in grade 10. You learn that in grade 10, okay, with 2 equations, 2 variables, but it's the same thing. Gauss elimination. Okay, cool. Right, we're going to pause here, and I'm going to do one exercise. It's got nothing to do with that, but it's something I saw in the book, and I think you maybe need a little bit of help on that one. Okay, so this is nothing to do with linear equation. It's actually a question that I saw later on with the determinant, calculating the determinant, but one with a variable. So this is, for example, something where a calculator is not going to help you. So you're told that this determinant, remember, a straight line, a curvy line means just a matrix, but the straight line we're talking about, it's basically the determinant of this matrix. We're told it's minus 20, find x. Okay, so calculator is not going to help you. So what we're going to do, there's 2 ways that I taught you how to calculate the determinant. I would do there's not 2 ways, there's just 1 way. But what I ask you to do is to choose the right row to use. Remember, you can use any row that you want, or any column. Okay, we will show you how you do it, but which row would you use here? The second one, because it has a 0. You want to choose the row with the most 0. We can also, by the way, use the column, but I don't know, I find it a bit difficult. I always just look at rows. Okay, maybe it is, yeah, anyway. So, what is the determinant here? Okay, we're going to write. Okay, so we're going to write minus 20, because I know that's the determinant, is going to be 0, okay, this element, time the matrix minus 4, 1, but I don't care, I'm not bothered about it because I've got 0, so I'm not even going to write it. And then I've got, okay, now I need to look at, then I've got minus 3, right? But what did I not do so far? The cofactors, okay? So remember, let's use another color. So they always start from a plus, and then plus, minus, plus, minus, plus, minus, plus, minus. And I know I haven't explained anything about that. I'll be honest with you. I
so it's okay, we believe you.
Yeah, I believe me as well, even though I don't know why. But let's just leave it. Okay. So this one was actually negative, if it matters. Minus 0, not that it matters. The minus 3 is plus, so it's minus 3 times the determinant. Okay. Right. So at this point, okay, remember we're using some like this. So I've got this determinant of this 2 by 2 matrix. Can you see it? Okay? So it's going to be minus 4, 1,
Wait, so is it for the
1
3?
minus 1.
Yeah.
No, wrong. Sorry, that was the 0. You're right. So I got to do like this, yeah?
Yeah.
It's kind of like Sudoku or something. I don't know. Okay? So I've got x1 minus 2 minus 1. Okay? Right? Okay? And then the last one, minus x. Now I'm going to do that. Okay, it's minus, yeah? Time x minus 4 minus 2, 1. Okay? We're not going to solve all of it. Okay? It's going to be a quadratic equation here, isn't it? But we'll just get to that quadratic equation. Minus 20, okay, equal minus 3 times minus x plus 2. Is that right? Because x times minus 1 minus x minus, because it's minus 2 times 1, so it's plus 2. Minus x times x. There's too many minuses here. Is this minus?
Yeah, it is minus.
So minus, 3 minus, so it's minus. So x minus 8. Okay? And I'll just leave that, okay? That's a quadratic equation. You can solve that for x. So there could be 2 solutions, and they're both valid. Yeah, I don't see any problem with that. Okay? Cool. We'll stop here. Yeah, next lesson we're going to look at back to a linear equation where either there is no solution or there's too many solutions.